Good afternoon, ladies and gentlemen. First of all, I would like to thank the organizers and all the people that have been involved for this very nice event. Due to time, I will have to rush a bit the presentation, but I will focus on the main points. The topic that will be presented will be LNG as marine fuel conversion for merchant vessels. Wärtsilä is a global leader in complete life cycle power solutions for the marine and energy markets. We have approximately 18,000 professionals in Wärtsilä and in 70 different countries. Our expertise in the gas value chain extends to several stages of the gas value chain, from exploration, storage, till distribution. Why LNG as marine fuel? This has been several times been discussed today. Of course, it offers a fuel compliant with legislation, emission, and as well, it can be cheaper. For new building, all major ship designers are able to offer a vessel with LNG as marine fuel for many merchant vessel types. Wärtsilä has a very extensive experience in dual fuel applications, different categories with many accumulated hours. We have more than 1,300 dual fuel engines, and we have accumulated more than 12 million running hours. And on this, I would like to state that we have many LNG carriers, Greek LNG carriers, that are equipped with the dual fuel Wärtsilä four-stroke engines. And actually, it has been very impressive, the investment of Greek owners from 2010 and onwards in LNG carriers, and nowadays they have approximately more than 10% in terms of number of vessels from the global LNG carrier fleet. So with the deliveries the forthcoming deliveries, this approximate 10% will rise. So it's quite impressive what the Greek owners have achieved. The challenges of LNG as marine fuel. As has been mentioned, it has certain challenges. Efforts from many different parties, such as class societies, manufacturers, and others, have all created LNG as feasible as marine fuel. Especially for conversion, integration of various systems is a challenge, but with good preparation, this can be overcome. Many design criteria are determining the tank arrangement on board the vessel, often having large consequences for the design and layout of the vessel. Significant difference in above deck and below deck arrangements. We have two types of tank process systems, one with pump and one with pressure buildup. Each solution has advantages and disadvantages. Now, regarding conversion, we can proudly say that we have achieved the world's first gas mechanical conversion, and this chemical tanker has been converted from conventional diesel fuel to LNG. Two tanks have been placed on board, each having a capacity of 500 cubic meters, and of course the engines have been converted in order to be able to burn LNG. The conversion work lasted 10 weeks from the arrival at dock to handing over the vessel to the owner after successful first bunkering and gas trials. On this slide, we can see the bunker station, the LNG tanks, as well as the tank connections to the tanks. It's also worth to mention that this vessel, after the tanks have been installed on the deck, due to the trim by the bow, it performed better than previously. This project had many different firsts. It was the first dual fuel conversion, the first LNG tanks delivered by Wärtsilä, as well as the first dual fuel mechanical drive. Here we can see the gas valve unit in an enclosure. This has been also a first for Wärtsilä, and this gas valve unit is regulating the gas pressure to the engines. Cooling and bunkering and risk analysis was done. The hazardous zone plan, where all the hazardous areas have been identified. Only the engine conversion, this was completed in 4 weeks. About bunkering, as we have seen also previously, we have track to ship, station to ship, or ship to ship. On this slide, we see a complete arrangement of station, tank, engine, and evaporators. The bunkering requires a certain procedure, first inerting the lines, decreasing the pressure in the tank, then filling, and then inerting again the lines. Here we can see a graph from bunkering of Beat Viking, where we can see the time required with the tank pressure and the filling level. And we can see that in order to bunker, you have to drop the pressure in the tank, then start filling, and then the pressure has to rise again. Another very important reference is for Wärtsilä concerning conversion. It's a Ro-Ro container vessel that it's in the US. It's the Totem Ocean, and it will be sailing 2016. This Ro-Ro container vessel has 2 tanks of 1,100 cubic meter capacity of LNG. And here we can see also the engines and the bunkering station, as well as the lines. On this slide, it's the process overview showing the tanks, the evaporators, and engines. Here we can see the tank that is being used on this conversion. This is a single shell tank, and we can see here on the right foundation. Actually, this is moving because of the expansion of the tanks. So the one foundation is fixed and the other one is sliding in order due to the expansion. And all of the penetration are in the dome, so we don't have bottom penetrations. Here we can see a reference list from the LNG tanks. In total, we have 52 tanks in 41 vessels, majority in new building vessels, and the majority it's double wall. And of course, we have them in various types of vessels. Here we have another vessel. This is the MS Ostfriesland that is in North Germany, and it has Wärtsilä dual fuel engines as well as a 45 cubic meter LNG tank. So to conclude, we can say that in order to introduce LNG as marine fuel, the necessary experience and in new building vessels and in conversion already exists. Efforts have been made by all stakeholders, and by having LNG, not only can a positive effect in the environment be achieved, but also more efficient vessel operations. I would like to thank you.